Now we'll take one somewhere. We'll keep it parallel to HP and perpendicular to VP, and let's see what we get. We'll do it with pentagon. Okay. Now, pentagon can be drawn in how many ways? First, that we'll understand. Pentagon can be drawn like this. Okay, first thing is how to draw a pentagon. How to draw a pentagon. So in order to draw pentagon, we first draw a line like this. This is equal to side of pentagon, let it be 20. Then we'll draw another line here, and the internal angle will be 108 degree. Then we'll draw another line here, and the internal angle will be 108 degree. This will be 20, this will be 20. Then from this point and from this point, we will take radius equal to 20 in compass and draw arc like this, and from here draw arc like this, and then join this and this, you get a pentagon. Okay, I will show it again. Draw one edge, draw line at 108 degree, draw another line at 108 degree. This is 20, this is 20, this is 20. Then with radius equal to 20 and keep it at any point and cut an arc. Then keep it at this point and cut an arc and join this. This also is a pentagon. We can also draw pentagon like this. Okay, you can name it A dash, B dash. Now this is not front view or top view, but considering that it is front view, we'll name it as like this dash, D dash, E dash. Are you getting this? Pentagon, how to draw pentagon?
Yes, sir.
Okay, I did not tell about hexagon, but hexagon can be drawn like this. There is circle method also. I'm not going to teach you that right now, but if you want to draw hexagon, a vertical wala hexagon, then what is the internal angle of hexagon? It is 120, 120 degree. All angles are 120 degree. Okay, so if this is 120, this is 120, this is 120, all these are 120. Okay, so you can find out how to draw hexagon and pentagon by these angles. Now we know how to draw pentagon. Now I will draw a solution, and again you people will now frame a question. So again we are taking the first quadrant, and in this first quadrant let this is the object, and the object is like this. So this is a pentagon. There is no distance from VP. And also if I name the edges just for your understanding, then it will be A, it will be A, B, C, then this point is D, and this point is E. Okay, tell me, what is the question? A pentagonal lamina. A pentagonal lamina 20 mm side is yes, come on, who will tell me? First you have to tell me with respect to HP.
Is 20 mm above HP.
20 mm above HP. Anything else with respect to HP?
Sir, vertex D, right? We'll say. No, we'll tell everything is above.
Sir, edge.
No.
Parallel to HP.
Yes, is parallel to HP, and what else with respect to HP?
Sir, 20 mm above HP.
Yes, correct. And 20 mm above it. Okay. Now define with respect to VP.
Perpendicular.
Perpendicular.
Correct. Is perpendicular to VP. Is perpendicular to VP. Okay. Now there is no distance between the lamina and VP, so it is the distance is 0. So next sentence. Next sentence with respect to VP, or how will you define the lamina? Otherwise, if I want to draw front view, top view, I can draw lamina like this also, no? I can draw like this also. This line is like this. No, I can also draw it like this. I can also draw it like this. Okay, with in
Sir,
front of the
side
plane.
AB
How?
is on VP.
Okay, very good. Side AB is on VP. Any other answer? This is correct. The lamina is perpendicular to VP.
And two of its edges are inclined at 108 degrees.
No. Perpendicular to HP, and one of its edge is resting on VP. Nothing is inclined. Nothing is inclined. You cannot tell about the lines of lamina. You cannot tell that this line is inclined to this line. Okay, that comes in basic construction of lamina. You are not allowed to tell this, that this line is inclined to this line. If it inclines, then the entire lamina will incline. See, the lamina is perpendicular to VP, and one of its edge is resting on VP. See, one of its edge is resting on VP. That is touching VP. So what will be the front view now? Let's see what will be the front view. So if I draw it like this, X line, Y line, X dash line, Y dash line, what will be the front view or top view? Yes, can anyone tell me?
So top view will be a pentagon, right?
Correct. How will we draw? Top view will be a pentagon, correct. So before we start drawing it, can we draw the front view first and then top view? Okay, I will answer. We cannot draw the front view. First, we have to draw the top view only. So how will you start? We'll start with like this. This is 20, then this, and then this, and this. This is the top view, and then we'll project it like this. We'll project it like this, and now we'll get the front view. So if I name it, then say this is A is here, so this will be A, A, B, C, D, and E, and we can write this as E dash. Pay attention, A dash, D dash, B dash, C dash. And then if I project it, I forgot to take this as projector. Okay, this will work. Okay, this one will work. Now I am trying to draw the side view like this, and then we project it here, and we project it here. What will we get? In the side view also we'll see one line only. That's it. And which points will come? How many points will come here? A and B. You can see A and B. A and B will come where? A and B will come here. A and B will come here. So it will be like this, where we'll have A. Where will be A? A will be here on this line, and B will also be on this line. Then on the middle line we'll have E and C, and on the last line, the last point here, that will be D double dash. See, is it clear to all of you? Also notice that the top view is touching the XY line and side view is also touching the XY line. Now why side view is touching the XY line? Because one of the view is touching the XY line. So this side view will also touch this line, this one, X dash or X dash Y dash line. Any doubt to any student in this?
No, sir.
No, sir, clear.
Okay, so we have seen all the cases where the lamina is either perpendicular to lamina is parallel to one plane and inclined to other plane. Now, okay, you can take the screenshot of this. Okay, now come to the first question. We come to this question. Okay, let us continue with this only. See now, this is a lamina. Okay, this is the lamina A, B, C, D, E. What is this? This is a pentagon. This is a pentagon, and this is just a lamina. Lamina means how many? How many surface? Only one surface. No, I am drawing it here again. I am drawing it here again like this. A pentagon. A pentagon like this. And now what I am giving is I am giving the thickness to it. I am giving thickness to it. So now I have given thickness to it. Okay, so since this falls in one line, so we cannot see other faces. We can see only this. So this is the pentagon, and the same name I will use here. So this is A, B, C, D, and E, and let this be say P. Now if I make it 3D, it will be more clear to you. Like this. Can you see this as a pentagonal prism now, all of you?
Yes, sir.
P, Q, then this is R, S, and T. Now see this. This is what you have understood, and you have also understood how to draw front view, top view, and side view. Now this is 20 mm above the HP, 20 mm above the HP. Now instead you compare this with this, and suppose this entire thing is resting on this HP, not above HP, not 20 mm above HP. Now instead of this plain lamina, if I keep this prism on this HP, if I keep the prism on the HP, what will you see? What will you see in the top view?
The top view will remain the same.
Same
Correct. Top view
pentagon.
will remain the same. All of you have understood this. Top view will remain the same. If I replace the lamina by the prism, top view will remain the same. What will you see in the front view? Front view यहाँ से देख रहे हैं. Okay. What will you see in the front view?
A
rectangle.
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 Correct. All of you will see rectangle in the front view. So instead of drawing a line, now we have given height to it. See, this is what we have given height to the lamina. So this is a lamina plane. Now if you increase the height, we'll get it as a rectangle like this. And side view will also be a rectangle, correct? That's it. That's the topic of projection of solid. Okay. So solid, I am not going to explain right now, but then this is the concept. So first, for that you need to understand inclination also of the lamina. Once you understand the inclination, then we can understand the solid easily. Okay, so you have just got a glimpse of how the solid projection of solid would look like. So wherever there is line, we will see a rectangle. Here also, if I give thickness to it, if I give thickness to it, then front view will remain the same. Top view will be a rectangle like this. Top view will be a rectangle like this. And side view will also be a rectangle. So in all the cases of projection of solid, we will see rectangle in one view. Definitely rectangle in one view, and other view will be the basic shape. Basic shape can be it can be a triangle, rectangle, square, hexagon. Other view will be a rectangle. And in case of projection of plane, one view will be a basic shape and other view will be a line. I hope this concept is clear to all of you.
Yes, sir.
Yes, sir.
Okay, students. ये सम एग्जाम में आता है. It comes for around 14 marks. Projection of solid. Okay. So now I am going to take a question where I am going to incline the plane. Incline the plane. So let us start with the square only. A square lamina 20 mm side is resting on one of its edge on the HP. The lamina makes 35-degree with VP. Draw its projections. Draw its projections. See, when you are solving this at your home, it's not an issue at all. But if you are solving this in exam also, you can consider any, you have compass, you have calculator, anything. You can consider it as a square lamina and try to keep it in the position which is given in the question, and you can solve it. See now, how will we solve this? So first I will make a lamina here. If any one of you can solve in your book, you can start solving, no issue. It is inclined to VP. Inclined to VP means it is making some angle with VP. Okay, this is the lamina. Let us name is not given in the question, so I will name it like this: A, B, C, D. And you can see the angle that it is making with XY line or with VP is how much? 35-degree. Okay, is the question clear to all of you? And the solution that I have drawn, is it clear to all of you?
Yes, sir.
In the earlier case, it was parallel to VP. Now it is not parallel to VP. It is making some angle with VP. Means this DC is coming close to the observer. Whereas A and B is at its place only. It's not moving. This D and E is making some angle and it is coming close to the observer. A rectangular lamina, 20 mm into 40 mm. Side is resting on one of its longer edge. I have made some correction in the question. Now, is this corrected question clear to all of you? A rectangular lamina. So you can see ABCD is a rectangle. 20 by 40. So one side is 20 So if I say this is 20 and this one is 40, and it is resting on one of its longer edge on the HP. See which is HP? This is HP, and HP पे क्या होना चाहिए? Longer edge. Which is the longer edge? 40.
40 mm.
करेक्ट. द लैमिना मेक्स 35 डिग्री विद वीपी. तो ये पहले कैसा था लैमिना? ये ऐसा था, है ना, ये ऐसा था. अभी इसका एंड ये पास में आ रहा है ऑब्जर्वर के, यहाँ पे देख रहे हैं, एंड इट इज मेकिंग एंगल ऑफ 35 डिग्री विद द वीपी. So can anyone tell me what will be the front view, what will be the top view? Dimensions of front view, top view. Front will be a rectangle. Okay, front view will be a rectangle. What dimensions can you tell me?
Sir 40 रहेगा ना sir? 40 by 20 sir.
Okay, 40 by 20. Okay, so this is 40 as you say, and this will be 20. ठीक है
सर, लेकिन वो इंक्लाइंड है ना सर, तो हमें कम दिखेगा ना सर,
कम आएगा
रहेगा, पर 40 से कम दिखेगा सर.
Exactly, it will not be 40. It will be 40 in which case? It will be 40 if it is like this, parallel to VP. Now since I have said that it is coming close to the observer, so at one point what will happen? At one point it will become perpendicular to VP, and when it will become perpendicular to VP, you will see it like this in the front view. What? A line. You will see only a line. It means that when it is not parallel to the VP, not parallel to one of the plane, and it is making some angle, then this 40 dimension will not remain 40, it will become less than 40. ज़्यादा तो हो नहीं सकता है ना, डायमेंशन बढ़ नहीं सकता है, कम हो सकता है. And what about this 20? 20 will remain as it is. 20 will remain as it is. No, in order to understand this, all of you take, if you have sketchbook in your hand, it's well and good. Take a sketchbook in front of you. Okay, hold it parallel to VP. Hold it parallel to VP and perpendicular to HP. Keep it on the table. It is on the table means it is on the HP. And its dimensions are, vertical dimension is 20 and horizontal dimension is 20. So its longer edge should rest on HP and the shorter edge should be perpendicular to HP. Okay, I have not mentioned this in the question, but it can be it is perpendicular to HP. So if all of you have kept the sketchbook in front of you in the first quadrant with longer lying on the table on the longer edge, which is 40, and the vertical dimension is 20. So all of you can see a square now of 40 by 20 side, correct? Hopefully you have done it, and you can see a square of 40 by 20, considering that the longer edge of your sketchbook is also 20 and the smaller edge of your sketchbook is also 20, 40 and 20. Now what you will do is, see, this is AB, this is AB. So keep, this is A, this is B. Now try to bring it close to you like this, close to you, and try to incline it at some angle, and slowly increase the angle, and keep watching at this vertical dimension as well as horizontal dimension. And remember that you are not watching it, you are not viewing that object close as you are. You are viewing it from some distance, and notice whether you see a decrease in this dimension. This 40, does it becomes less or more, or at some point does it become 0? Yes, your answers.
Sir, at 90 degree it will become 0, right?
Sir, it becomes
Correct. If it is per 90 degree, मतलब कैसे बोलेंगे हम उसको with respect to VP?
perpendicular to VP.
Perpendicular to VP.
Perpendicular.
Correct. So in that case, it is perpendicular to HP as well as perpendicular to VP, right?
Yes, sir.
Yes, sir.
And we will see a straight line in the front view. So what is the length of that straight line? Does it remains 20 or it decreases?
It will remain 20.
Sir, it will remain
Correct.
20 always.
Okay, all of you have noticed this. It will remain 20 only always. Okay, it will remain, this will remain 20 only. But this horizontal distance, which is 40, this horizontal length, which is 40, is reducing and it is becoming 0. So we are not making it perpendicular to VP. So it will not be 0. It will be less than 40. It will be less than 40. So we cannot draw the front view here because we don't know this distance. We don't know this distance. ये कितना है पता नहीं हमको. So we cannot draw it. ठीक है. What we can draw is we can only draw this line. We can only draw this line. बाकी का 3 लाइन हम draw नहीं कर सकते. Now, what you will see in the top view. अच्छा, before that, any doubt to any student in this? Any doubt in this front view?
No, sir.
Clear to all of you?
Yes, sir.
Yes, sir.
Okay, now talking about the front view. So what you will see in the talking about the top view. What you will see in the top view? Top view.
The line.
Sir, a line inclined to VP.
Line inclined to VP at what angle?
35.
35.
And what is the
35.
length of that line?
40 mm.
40 mm.
So this is the view that you will draw, where this angle is how much? This is 35 degree, and then you can name it. Whatever is the name, and then so we cannot draw this first because we don't know this dimension. No, is this resting on HP? Is the plane resting on HP?
Yes.
Sir.
So where you will get front view? How much distance away from HP?
0.
So you will get the front view, which will start right from here, like this. Like this. And if I name this now, then it can be named as, say this is A dash, this is D dash, this is C dash, this is B dash. And if I dimension it, then in that case, this dimension should be how much? This should be closed and filled arrow with 20, and this dimension will be 40. This dimension will be 40. Like this. And how will I name this points as? This point will be A, comma B. This point will be C, comma D. A, comma B, C, comma D. And if I want to draw the side view, then what I will do is I will project it like this and like this, and also I will project it vertically upward. And I will project this as well. And now in this box, my side view will fit. Okay, it will not go beyond this block, beyond this box. So it will fit here like this. And if I take the reference from both the views, on this line I should get A and D, and on this line I should get B and C. And if I take the reference from the top view, on this line I should get A and B. So A intersects, so this will be A double dash. B intersects here, so this will be B double dash. This will be C double dash, and this will be D double dash. And this is the complete solution of the question. Is it clear to all of you? Any doubt, students?
सर टॉप व्यू में ए और बी का डिस्टेंस नहीं दिया है ना?
हाँ, टॉप व्यू में ए और बी का डिस्टेंस नहीं दिया, so this distance is not given. Okay, good question, very good question, because this distance we used to give this distance up till now. Now this is not given. Nothing is mentioned about this. So what will be this distance? This can be any distance. Now what do you mean by any distance? Any distance will be, देखो अभी इसके ऊपर हमको कुछ नहीं लिखना है, so we can take it approximately as 20 mm. So this is approximately. मैं नहीं बोल रहा हूँ, ये people can tell you 20, 25, 30, 45 कुछ भी ले सकते हो, 100 भी ले सकते हो, तो 100 कितना दूर चला जाएगा? So approximately 20 mm. So if you want at all to give a dimension, then that can be given at distance of 10 mm. So this distance is not given. So most of the time what will happen, the distance of the lamina from HP and VP both will not be given. Both will not be given. So you have to draw it at some distance, convenient distance, suitable distance. Okay. Is this clear to all of you?
Sir, I did not understand side view, sir. Side view, I thought, sir, it will be a line only, na, sir.
Okay, how side view will be a line? No,
Sir, it
side
will not be
view.
a line, sir. These both lines will be close together, na, sir. That I added out.
Yes, both lines will be close together, but how close? That is decided by the top view. This top view will decide because AB is here. See AB, you are viewing the side view from here. कहाँ से देख रहे हैं side view? यहाँ से, ठीक है? So AB is here, A and B is here, and if this is parallel to VP, then DC will be in the line of AB as we have drawn up earlier. But now it is moving here, so this distance, ये distance यहाँ से यहाँ तक. So if I want to show you that distance, it can be shown like this. It can be shown like this. So this distance and this distance. This is the distance of the side view. So that is dictated by which view? It is dictated by the top view. Top view will tell us how much will be this distance of side view, how much will be this distance of side view. We don't have to do anything for that. It is automatically coming because this is 40, this is 40 that we know, this is 35. So by dimension, wherever it comes, it will be like that. Okay. Now since this is not drawn to the scale, I don't know whether this is exactly 20, this is 40 or this is 35. This is drawn, everything is drawn freehand and not to the scale. So you may see that, okay, this is more. It may happen. Is this concept clear to all of you? Projection of planes, how difficult it is?
Yes, sir, understood.
Yes, sir, understood.
Understood.
Is it difficult at all?
No, sir.
No, sir.
No, sir.
Okay,
No,
so
sir.
if good student, so if you start visualizing this now, if you start visualizing this, okay, you will be easily able to draw these views. Now you have drawn one somewhere, we have made it inclined. Okay, similarly now we will make this inclined to HP. We will have question where I will say that it is resting on one of the corner, it is resting on one of the edges and all those things. It is resting on longer edge, it is resting on shorter edge, something like this. So you can take the screenshot of this and we'll see the next question. So if this is clearly understood to you, projection of plane is not, projection of solid is not at all difficult. And in fact, in this earlier sum also, I have told you how to solve projection of solid sum.